Okay, so starting a page of notes here for 3.3, Foundations of Math 10, from your Foundations and Pre-Calculus Mathematics 10 textbook by Pearson Company. 3.3 starts on page 150, and we're talking about common factors of a polynomial. So we've talked about common factors of separate individual numbers and terms already, if you recall. So we've also talked about perfect squares and perfect cubes. So greatest common factors are something we're going to go back here to today. And how many of you know what algebra tiles are? What algebra tiles are? Okay. We might use some algebra tiles in some of our lessons here in the next little while. I'm not going to stress algebra tiles. If you really appreciate algebra tiles, that's great. I'm going to show you some examples on how algebra tiles can be maybe helpful, but we're not going to focus on using algebra tiles. I'm going to tell you just how to sort of factor binomials and trinomials without algebra tiles, and I think it should be pretty understandable for you. But with algebra tiles, the tiles themselves, the long skinny ones, represent a single variable like m or x or y or whatever it is, the variable. So this would be 1m right here, this one of these. And then the individual little squares are the ones units. So now if we consider factoring an expression or writing an expression as a multiplication of two things, there's different ways you could do this. Okay, this setup right here with these algebra tiles, there is one single row. It's a width of one unit, and then we have a length of 4m plus 12. So to write this as a multiplication statement, we have 1 times 4m plus 12. Think about this. It's a rectangle with width 1 and length 4m plus 12. Okay. Now there's another way. We'll do this soon. But there's another way we could. Well, there's a couple of other ways we're going to do it here to also write this as a different multiplication statement. So think about this. We could rearrange these tiles into two identical groups here. Okay. Now we're not multiplying the two identical groups together, but instead we're thinking about this as a rectangle. And what is my width and my length? So another way that you could factor or break up 4m plus 12 is a width of 2 units and a length of 2m plus 6. So 2 times 2m plus 6. There's another way that you could factor 4m plus 12. And there's a third way you could factor 4m plus 12, and check this one out. Notice that the algebra tiles still form a nice, neat rectangle. And we count the widths, so 1, 2, 3, 4 units wide, and m plus 1, 2, 3 units in length. And so another way we could factor 4m plus 12 is 4 times m plus 3. Okay? So when you can arrange algebra tiles in some kind of square or rectangle, a complete rectangle, then you can factor that expression, that binomial or trinomial, whatever it's going to be. If you can make a rectangle out of it, then you count the width and you count the length, and you multiply those together. Those are the factors, the width and the length. Okay? Now, consider this, all right? Compare multiplying and factoring. All right, so we know that multiplying, what multiplying is, and we know what multiplying is in arithmetic form. So if you have a 4 times 7, that's multiplying. 4 times 7 is 28. That's 4 groups of 7, 28. If you want to factor a number down, you can factor it into its prime factors, but you can also factor it into just two regular old factors a lot of times, right? And so 28 could be factored one way by separating 4 times 7. So factoring is sort of breaking it apart into two things that are multiplied together, two or more things, and multiplying is kind of combining them together. Now in algebra, when we have letters and different expressions that are more than one term like this, multiplying is, you think about expanding, okay? So to expand an expression to form a product, that's like multiplication by expansion. So watch what happens here very carefully. I think you've seen this before last year. But if you have a number 3 times a binomial 2 minus 5a, what you're going to do is you're going to take that 3 and you're going to multiply it in separately to both terms. So 3 times 2, you write that down, 6. And then 3 times negative 5a is negative 15a. And you write that down, and there's your expanded, your expansion there, or your multiplication of those two factors, okay? So the other word you want to notice here is distributing, okay? To distribute. Okay, we basically take this 3, this multiplier out front, and we distribute it to everything that's in the brackets. We multiply it by everything. So we kind of give a little bit of a 3 to this, and then a 3 to this, and a 3 to that. We distribute. Now factoring is what we're going to focus on here in this lesson, factoring polynomials. So if you think about factoring at the most basic form, what it is it's breaking down a binomial or a trinomial into factors, so two things that are multiplied together. Okay, now we can see, because we just multiplied this out, we can see how we can break up 6 minus 15a, right? I can remove a common factor, and that's the thing, remove common factor from both terms, and then write whatever's left over when you divide that factor out. Okay, so I'm going to actually write that down before we do some more examples, just as a little bit of notes. So let me just get back to a regular Zoom here. Okay, so I'm going to make some space and write this little note down. Okay, one way to factor, write this down please. A polynomial is to determine the greatest common factor, the GCF, for each term and divide it out to form a multiplication statement. Okay, and I'll give you some examples of exactly what I mean there. So if factoring is breaking a number or an expression, like 6 minus 15a, if it's breaking it up into two things that you can multiply together, the first thing you're going to do is look for a greatest common factor. Because if there's one number or one term that you can pull out of everything, that's the first level, first step of factoring. So we are going to do that with these 3 examples right here. And I'll move this one over down here, I think. Okay, so we are going to factor out greatest common factor from a binomial. So this is the first one. We'll call this A. And there's our example. 1. Okay, so there's different ways you could do this. I'm going to teach you by doing it this way, and I would like you to try this. Write 2 as a factor of either prime factors or prime factors are what we're going to look for here. So that's going to be just basically 2 just becomes 2, right? Or 2 times 1. So I'll write this as 2 times 1. 4 as prime factors would be 2 times 2 times a. Okay, so it's important for us to note that we're going to have letters, we're going to have variables in here, and so we have to consider those as factors as well. So if you have 1a, it's just 1a multiplied. All right, so now what you want to do is look at this list and say, what's my greatest common factor? So I have a factor of 2 in both of them. Do I have any other factors in both of these brackets? Nope, that's it. So I am going to pull 2 out as a common factor. And now I'm going to write the expression of whatever remains. So I've got 1 minus 2a. That's what remains. 1 minus 2a. And there you go. You've factored the greatest common factor out of this binomial, and that is now completely factored. Okay? So what you want to do is you want to look at these terms and figure out in your head, or figure out by prime factoring, what are the common factors for each one, just like we did the last couple sections. All right, let's go to number 2. All right, so number 2. So I'm going to write 3x squared in prime factors. That's going to be 3 times 1. And yes, we are going to do 1 here as a prime factor because you'll notice that 1 is actually pretty important in our division formula. So I am going to do the 1s, and I would encourage you to as well. Times x times x. So write each x out separately. If there's 2, if it's x squared, that's actually x times x. Okay? Plus, now 12 in prime factors, you can think of just regular factors. Okay, 4 times 3. Oh, but 4 is 2 times 2. So I'm going to go 2 times 2 times 3, and then times x. And again, this is the way I want you to start doing this, because this is very methodical. It's very easy to see. You're going to be doing a lot of this in your head coming up soon. So what's common to both? Oh, I see a 3 in both lists. You guys see that? I also see an x in both groups. Is there anything else that is common to both? No. So I pull out a 3x. 3x is one factor. And you can put brackets around that if you want. What's left over when now really what I'm doing in these cases is I'm dividing my common factor out. So you have each. So you can envision this as a division. Well, what's left if I divide 3x out of 3x squared? 1x, or just x. You don't have to write 1 as the coefficient. All right, I will for now. 1x, because that's what's left over. See? 1x. And those are gone. What's left over? Okay, it's a plus. And what's left over? These go, what's left over? 4. So 3x is one factor, and x plus 4 is a second factor. And to verify that, because you'll have questions where it'll ask you to check or verify, all you do is you now distribute. So let's verify over here first for this question. We didn't do that. But if I were to verify, that means I would have to now do the opposite operation, which is instead of factoring, splitting them up, I want to put them together. So I'm going to multiply them in. So 2 times 1 is 2. 2 times negative 2a is minus 4a. Now that's the same as what I started with, so it is verified. On the second one, I go 3x times x is 3x squared. Then I distribute again 3x times 4, which is plus, because there's a plus there, 12x. And if that's the same as what you started with, then you have factored correctly. So this is your factored answer. Okay? So I'll do one more with you. This one might be a little bit tricky because it's got multiple letters, but I don't think it should be tricky for you. It just might look a little bit strange. So we're going to factor each one. So this is going to be 2 times 2 times a times b times b. Notice there's b squared there, so that's 2b's. This one's going to be 2 times 5 times a times b. So what is a common factor to both, or what common factors do we have here for both? Well, I have a 2 in both lists, I have an a in both lists, and I have a b in both lists. And that's the maximum number of letters and numbers as factors that I can sort of pull out. So I am going to now realize that my greatest common factor is 2ab. You see that? That's common. So 2ab is my first factor. And then what's left over, really, and you can do this is pretty easy. You can just do that. When that's gone, now you have 2 times b, so that's 2b. Plus, just cancel these out. Have 5a. That's what it should be. So let's check, let's verify. 2ab times 2b, that's going to be 2 times 2 is 4. A times, well, there's no other a, so there's just a. B times b is b squared. When I distribute this to the second one, this is a plus 2ab. We know it's not negative, so plus times plus is plus. And then 2 times 5 is 10. A times a is a squared. B times, well, there's just nothing else there, so I just write the b. So is that the same as what I began with? Yes, this verifies. So that means my complete full answer is this right here. Question? Okay, if you factor something out and you don't have the greatest common factor, what you'll notice is that there will be another common factor inside one of your factors. And if there's a common factor inside there again, then you have to factor that out again. You might not have just gotten everything. Okay? And maybe we'll do an example like that later. But anyways, so how does this translate to a trinomial? Well, it's pretty easy actually. We do the exact same thing. So the long way, again, 5 times 1 minus, doesn't take us long, but this is going to be 2 times 5 times z minus 5 times 1 times z times z. Okay? All right. Now, what's common to all three? There's a 5. It's common to all three. Anything else? No. Ones, if I were to write a 1 over here in the middle as a factor, you don't have to, but obviously a 1 is a common factor to everything. So that 1 only comes important when you've divided everything out except for a 1. You don't want to leave it as a 0 or blank. So you'll understand what I mean. We do more examples. So I just take out a 5, no problem. 5 is my common factor. And then what's left over? See, when I get rid of that, if I didn't have the 1 here, this is what I mean. Then then a lot of students say, oh, it's nothing. So I don't have to put anything there. No, you do. You have to put a times 1 there. So this is 1. Because 5 divided by 5 is 1. If we would expand this, 5 times 1, it wouldn't be 5 times 0 is 5. It's 5 times 1 is 5. So you do need this 1. Okay, minus 2z minus 1z squared or just z squared. You don't need the 1 as a coefficient. You do need the 1 if it's a constant. So let's just check this out. Verify or check. 5 times 1 is 5. 5 times negative 2z is negative 10z. 5 times negative z squared is negative 5z squared. Is that the same as my original?
Yes.
It is. So that means that this is my final answer right here. And if you have a single term like this, you really don't need the brackets. You can have the brackets, but you don't need the brackets. So you could just write it like that as well. Okay? Sometimes you'll be able to pull out a number that's a common factor. Sometimes you'll be able to pull out just a variable, or sometimes it'll be a number of variables, or sometimes it'll be a number and a variable. And then next section, we will do some more factoring of trinomials. Okay, do this one on your own. See if you understand what's going on. This looks pretty tricky, but do it exactly the same way that I showed you how to do it, and verify to make sure that you're correct. So I'll give you a couple minutes to do that. So this is factoring a greatest common factor out of an expression. And like I said, don't forget that the negative is actually a common factor here as well. So when you pull that negative 1 out, you can actually write each terms as a sum then. Okay, so here's your answer. Negative 4xy is your common factor, then 3x squared plus 5y plus 4xy is the second factor. Any questions? Okay, let's move to some of your assignment questions. I'll do some of those with you. So let's take a look at number 5. Write down what you need to write down there, please. Okay, so number 5 says factor the terms in each set, then identify the greatest common factor. Okay. All right, so 6 and 15n, if we factor these, this is 2 times 3, right? 2 times 3. And if we factor 15n, that's going to be 3 times 5 times n. You good with that? What's the greatest common factor here? GCF is? Yep, just 3. That's the only thing that's common, only factor that's common to both. So GCF is 3. Let me zoom in just a bit. All right, so for 4m and m squared, this is going to be 2 times m. And this is going to be m times m. So what's common here is, looks like just a single m from both lists. So the common GCF is m. All right, so now that we've done that work in 5, question number 6 says, use the greatest common factors from the questions in 5 to factor each expression. Okay, so let's do that. I'll zoom back out a bit here. So so let's factor this, okay? So between 6 and 15n, what's my greatest common factor? 3, right? So you always put the 3 outside the brackets. And then what's left over when I take the 3 out of 6? I divide 6 divided by 3 is? Somebody shout it out. 2. What's 15n divided by 3? 5n. Plus 5n. Okay. What about number 2 over here? Okay. So greatest common factor again is 3. So that's going to be 2. This is a minus now, right? So it's going to be minus 5n. Third one, 15n minus 6. If you switch them around, guess what? The greatest common factor between those two is still just 3. But I have to write 5n first, because it's the first term. Minus 2. And the fourth one over here, greatest common factor is still positive 3. I write negative 5n here. See, because of the negative sign there. Plus 2. And again, to make sure you've got these right, just do a quick expansion or a quick distribution in your head even. And you go, for this last one, 3 times negative 5n is negative 15n. And the 3 times 2 is plus 6. So yeah, you've got what your original. All right, for B, the greatest common factor is just m. So I'm going to take an m out. And I'm left with 4 plus m. Okay, and you can simply just think about dividing each. I often do that, think about dividing each, and what's left over, that's what you put in the brackets. So number 2, take out an m, that's your common factor. So I'm left with m plus what? Shout it out. Yeah, what's 4m divided by m is? Just plain old 4. M is my common factor. I'm going to write a 4 there, because that's what happens when I take the m out there, minus m. And the last one, take out an m. I'm left with m minus 4. Capiche? Understand? Any questions? All right. Some of your assignment questions will say use algebra tiles. You do not have to use algebra tiles, okay? It's okay. So, again, I'm not big on algebra tiles for factoring binomials, trinomials. I think if we take a look at each individual term and the factors of each individual term, we can identify what's common to both, and that's the way that you're going to do it as you move through high school and university anyways. So anyways, so let's take a look at 9a together here first. All right. Now, can any of you see what is a common factor between these three without taking the prime factors out? What's the greatest common factor from each of these three terms? What's your guess? I see a hand up there. 3. Okay, so 3 can be divided out of 3, can be divided out of 12, and out of 6, and it is the largest number that can be divided out of each. Good. The variables, well, this term does not have a variable, so we do not have a common x to each term. So yes, just 3. Excellent. So if you can go straight to this without writing the prime factors, go ahead. If it's still a bit fuzzy, then write each term as prime factors like we did in our examples, and then go from there. But yeah, if you can see that 3 is the greatest common factor, when you divide 3 out of 3x squared, you get x squared, right? Remember, view this as a multiplication if you want. 3 times what gives me x squared? Oh, 3 times what gives me 12x plus 4x, right? 3 times what gives me negative 6? Well, 3 times negative 2. So you can view this as a dividing of your greatest common factor out, or you can view it as 3 times what, as a multiplication. So just a quick check. 3x squared, yep. 12x, yep. Negative 6, yep. There's your factored for A. B. Okay, what's the greatest common factor between these 3 terms here? Is it 4?
2.
It's not 4 because you can't divide 6 divided by 4 evenly, right? You'll have a decimal. So that means it's not a factor. So yeah, 2 would be the greatest common factor. There's no y in this term, so it's not a y. So 2, excellent. So 4 divided by 2 is 2. Negative 6y divided by 2 is negative 3y. Negative 8y squared divided by 2 is negative 4y squared. Another way to check each of these factors and see if you can break them down, factor them any further. If you see a common factor, again, that means you didn't take the greatest common factor out. That's all that means. So if there's no common factors between either of those, then that's great. So 2 is just itself, so you can't break that down any further. But if there was a common factor in these 3 terms, then you'd have to do that again and pull it out again. All right? So you want to get to the greatest common factor in the end. Okay? All right. You guys do C. Take a minute and do C. Go ahead and do C and D, maybe. All right, take a minute, do C and D, and you can check your answers with mine. Okay, so for C, as I mentioned here, I'm going to break each term up into its prime factors for any of you that still want to do it that way. And I do see a negative. That is a common factor for all 3. A negative is a common factor. And a 7 is a common factor. So negative 7. And what's left over when I take a negative and a 7 out? Well, m, negative and a 7, plus m squared. A negative and a 7 is plus 2. And if you multiply those in, negative 7 times m, yep. Negative 7 times positive m squared, negative 7m squared, yep. Negative 7 times positive 2, negative 14, yes. All right. Okay, D, I'll go back to the way that probably most of you are going to default to, and that's probably not the prime factorization of each term. So I'll do that one again with you. So I would suggest that you look at these numbers first, and look at the numbers first. Can you divide a 6? That's the smallest number. Can you divide a 6 evenly out of each of those numbers? You can out of 12, but not out of 10. So it's not 6. We're going to have to go down lower. What about 3? 3 can divide out of here and here, but can 3 divide out of 10? No. So we got to go to 2. Okay, so 2 is my prime, or is my greatest common factor because there's not an n. There's not at least one n in each term. So when I take a 2 out, 10n divided by 2 is 5n. Minus 6 divided by 2 is 3, and then minus 12. And negative 12n squared divided by 2 is minus what? 6n squared. Okay, let's check to see if that seems to work. 2 times 5n, 10n. Good. 2 times negative 3 is negative 6. Good. 2 times negative 6n squared should be negative 12n squared. Good. So here's your answer. Please let me know if you have any issues with those. Any questions? Okay, hopefully you tried those C and D and were able to get those answers on your own. Okay, so here's your assignment. Again, you do not have to use or sketch algebra tiles for these questions. You can either use the prime factorization method, or you can just consider each term and determine the greatest common factor for each term. Please show your work, though, as much as possible. And yeah, there's your assignment. And maybe tomorrow, if any of you have problems with 16, we can go over something in 16 if you need to.
So 3x, there's 3 x's left, but then 5y. I'm pretty sure this is what you wrote down, but like, I think there's only 2y.